So first of all, let me introduce myself. So my name is Sandesh. I'm basically from Pune, India, and I have around 4 years of experience in IT now. I've worked with Ruby, Java, and I also like some DevOps work as well. You can say full stack engineer, but not much into front end side. I mostly work with Ruby and the back end side, I can say. And basically, the pattern is my current company where I'm currently working as a software engineer. And today's topic is DDD with Ruby. I'm not sure how many of you heard about the DDD, like what is DDD and uh, how we can implement to the Ruby. Like that is something that I'm going to walk you through this session. Okay, so I think there is some problem. Yeah, cool. Okay, so the agenda of this session, the first thing is what is and why DDD, why we really need DDD, and how DDD approach helps us to scale and maintain the application in a good way. I will also going to walk you through deep into the DDD, what exactly it is. Then the DDD with the hexagonal architecture. So hexagonal is the term is you might thinking about this is something difficult to understand, but it is really simple thing that I'm going to try to explain in a simple manner. And I have also have a snippet that currently in my previous organization we also do the coding with the domain driven approach. So I will also share you the snippet and the how the code structure will look like using the DDD approach that I'm also going to walk you through. Okay, so that's about the today's agenda. So first thing is like, what is DDD? So basically, as a software engineer, we always intended to be solve the problem in a better way. Like if some problem comes, like we always think about it, like how to solve it and how in a better way we can find a solution of it. And we have a lot of frameworks of that, like using multiple frameworks we can design APIs, we can connect database, and we can uh, we can create an full-fledged application. So DDD is nothing but a software design is driven by the domain. And what is domain? Domain is nothing but your software is evolved around it. And domain is a subject area where the application that being developed is centered. So what is that? So basically, domain driven is an approach when we build an application. We think first about the business, not the technical thing. And I mean, the technical thing is the part of the software, but we consider the business, the core models that I'm going to explain in next slides as well, what is exactly the domain models and all. So this is all about the DDD in a simple way, like what exactly it is. Okay, so basically, this is the diagram. I know this diagram is overwhelming, but this diagram is directly I copy pasted from Eric Evans' DDD book, and which is nothing but I just mark the cross line so we can understand in a better way. So DDD is basically have a two parts. One is strategic and one is tactical. Maybe the next screen, this is the strategic design. I just zoom in, and this is the strategic approach. So what is strategic design? So DDD having the two parts, strategic and tactical. Strategic is nothing but how your application is around. I mean, not around, maybe you can say where your application stand in the organization. Like let's take an example, you are a civil engineer, okay, and the client approaches you, like he want to build a house. Then you will think like you will ask the questions like, what kind of house do you want? Then he will say like, I want a farmhouse. Then you will ask like, what kind of things you need in a farmhouse, and what is the use of the farmhouse, like for what situation and when you are using the farmhouse and all. So in this case, you are just an engineer. You know how to build walls, how to design things, how to do the calculations and place the right wall on the right place. But in this case, the domain expert is nothing but your client. Like he will tell you like these are things I want, and these are things I don't want. And by thinking of all those things, you will design something like this. Like, yeah, in the farmhouse there can be a barn, there can be shade, there is a farmhouse, there can be a stables, and based on this, you will design something like this. This is nothing but, I hope my pointer is visible. So using this, you can design like something like this. And the language, the way we try to add here, like this is the barn, this is the shed. So these are nothing but the ubiquitous language. And in the particular farm, you have a multiple stables and different things. Those are nothing but the bounded context. So what exactly ubiquitous language is like? When you are developing in a software, the domain expert and the analyst and developer. So these are three, you can say the section or the folks, those who are considering to build your application. So they all three should be on the same page. So you should have a common language of defining a model, or defining a term, or defining a particular situation. You can't directly directly tell your domain expert or analyst the technical words. So they might not get the understand the things. But so the ubiquitous language comes in a picture when we have to write something, you have to design something, and you have a particular domain expert and analyst having different things. So ubiquitous language will help us to design our data models throughout the application. I mean, suppose you have one application, and that application end user is patient. So you can't name it as a customer in our code. Like, so all the code you are writing, it should be in model. I mean, whatever you model you are writing, whatever methods are you writing, whatever classes you are writing, it should be defined by the ubiquitous. So this is like about the ubiquitous in the common language. So what is bounded context? So bounded context, suppose let's take an example of the e-commerce. So e-commerce is the very much vague concept. Like it is like it has the sales, it has suppose accountings, orders, some logistic department, and each domain having their different domain expert. So like whenever you are building something, and that is something on a large scale base, you have to think about like how to deal with the large domains. You can divide the models you have into different zones. You can have a different zones, and those zones are nothing but the bounded context. In this case, there are sales, supports, accounting, orders. And this gets familiar when we create a proper microservices of each domain, each bounded context. It's not intended to be every time you need a microservice, you can create a monolithic application as well. But the bounded context, you are segregating the application, you are moving out the code from you are managing code in a different way. That is the important thing. Because the reason is like for every department having their different domain expert, and based on that we have to manage things. So these are nothing but the bounded context. Let's get back to the last example that where I talked about the farm. So these are nothing but the blue circles are nothing but the bounded context. These are different sections: the farmhouse, the barn, the stables, and the caretaker here. So for example, caretaker in a barn, it might be different case in a stables. Like caretaker in a farmhouse can be different. Caretaker on a main gate can be some different. Like he can be a security guard. So each domain model or each domain model behavior might be different in a different bounded context. So that's the reason like we can build different APIs, different DB, we can separate out things for the large scale application. Even for the monolithic application also, we can think in a way so that we can segregate these things. So this is about the strategic design, where this is nothing but how you design your microservices over the organization. Like if your application is an e-commerce field, then the e-commerce have different microservices or different bounded contexts like this. Let's get back to the tactical design. I mean, in the first slide, I'll show you there are two types. One is strategic and tactical. And tactical are nothing but more intended to be how you design your code, how you write the services, how you write the repositories, how you write the aggregates, the factories. So basically, these terms are familiar, like aggregates, the factory services. Those are come from the DDD itself. Those got famous because of DDD. And let's get deep into it, like what exactly is the tactical design. So this is very important layer, like in the layered architecture. So basically, what exactly layered architecture is? So layered architecture basically segregate our code based on the maybe you can say the user interface, the application layer, the domain layer, and the infrastructure layer. So basically, what is happen when we write a code in a Rails app, for example, sometimes we indirectly wrote a code, business logic over the controller side, or or maybe we use an anti-pattern like the decorator or some other things, and we mess up with some code. But the layer architecture will help us. Like I will give you a demo about this, like how you can segregate code, how you segregate the business logic. So there are basically the four phases: the user interface, where we have to just process a user request. The application layer is nothing but which handles the serialization and all those stuff. Domain layer is the very important thing, where exactly your business logic is there. And infrastructure layer is nothing but how you connect, like all the connection part, the deployment things, and all the stuff should be in the infrastructure layer. So this is about the layer architecture. So also one more thing, like these are there are the value objects and the entities. So value objects are nothing but, let's take an example, like suppose you have a $100 note, and it should be $100. It can't get changed. Like it should not be 500 in next day. It is $100, so it is $100. So value objects are nothing but they are immutable. They cannot mutate the whatever the value that got assigned. It really value object don't care about the uniqueness. Reach in domain logic, and it is auto validating. Next thing is entity. Entities are nothing but, you already know the active record thing. The active record thing is nothing but it is the ORM. So it has the uniquely identify by ID. Consistent of value object generally persists as a row in a DB. They are typically mutable, and they basically persist our data in the database or any other whatever storage you want. Next thing is the aggregates. So what is aggregates? Aggregates are nothing but, let's take an example like customer info and addresses. If something got changed in a customer info or address, so customer should get changed. Like these are dependent things. Like one customer has one customer info and one customer has many addresses. So these are dependent. Or let's take one more example: order info and order item. If something got changed in order item, it should change the order. If we delete the order, the root aggregate, this is called a root aggregate, then all other entities which are those are dependent on the order, it should get deleted. So these are nothing but the aggregates, like how you can how it should be, and what is the behavior of that. Next thing is factories and repositories. So you already know about what is the factories and what is the repositories. So factories are nothing but, I'm not sure you're able to, oops. Yeah. So nothing but factories and repositories are nothing but the mixture of the entities and values. Based on using the entities and values, you can create an aggregates. and factories helps to create a new aggregates, and repositories helps to persist the aggregates, what we have defined in the entities and values. So these are this. Let's move to the hexagonal architecture now. I know these are more or theoretical things, but this is quite important to understand what exactly use of this. So let's move to the implementation thing, like how we have achieved DDD with this. So this is basically a Sinatra based application. Why we choose Sinatra? Because the Rails having lots of contradiction with the because it follows the MVC, and it's getting difficult for us to managing things in a like overriding things will getting critical. So that's why we use a Sinatra, and Sinatra definitely is like flexible thing. We can anytime we can override things. I mean, we can create whatever the folder structure you want. So this is something I have defined: API, connector, core, and the event. So these are the important folders. So what exactly it is? So basically what API does, so I have defined one user controller over here, and inside the user controller, so the job of the API layer is just taking an API request from the user, and whatever response is coming from the core service, that is the user service, we have to just serialize it and just send it back. That's it, nothing else. So this is the only use case of, I mean, only use of this layer, the API layer. You can see in the code, like I have defined the user controller. Here I have injected the user service over here, and I'm calling the user service from the API layer, and directly I'm calling the user service. Nothing is doing, like just in a simple way, and just rendering the JSON with the user serializer, with the help of user serializer. Whatever serialization we have to do, you can do it from here itself. So this is about the API layer. And even you can write the spec. Even I have created the spec folder over here, and you can write only specific test cases which is oriented to the API layer. That's it. We have to just send it API, and we should expect it should be okay. So this is about the API layer, and there is the user service. If you go back to the bit down, there is a core service, and in the core service where I have defined the domains. So these are our domain model. This is the user domain model, and don't get confused with the active record model. Active record is a different thing, and the domain model is the different thing. And the domain model have the name and email, and in the services, like in the user service layer, here exactly in the core we can write our business logic. Whatever the business logic we have, we should we should write that code in the core itself, and nothing fancy. Like we don't have to write any database query. We don't have to write anything like connecting to Stripe, for example, or connected to any payment gateway. It's just a simple like step of actions which is related to the which is related to your business logic. And the next layer is the connector where the entity and the active record things comes in a picture. And we basically the flow is like when you send a request to the controller, it go to the core layer, and from core layer we just call the connector layer. Connector layer is nothing but the repository layer. The user repository is here, the connector database is here, and what we are doing, we are just doing like the domain user, and we are just, this is nothing but the active record model. We are just inherit from that, and basically it's just calling the active record query user.all, and we are just mapping and sending back to the core response. So this is basically how I have segregated things to core, connector, and through these three folders. And there is one more folder like event. Whatever the events are coming from, for example, there is one webhook that you have integrated. That is basically all the webhooks comes here. So this will become our code very much segregated, so that you can write your code and For example, let's take an example like tomorrow we don't want APIs. We are not supporting an API JSON response. We have our logic only here in the core, like the whatever we have in whatever the business logic we have. So tomorrow you just need to say just need to create one folder, and you just need to call the services. That's it. So this will this will make easier to change from one input to another input. So this is the flexibility of the hexagonal architecture provide. And one more thing about like database is the simple thing, like the similar way in a Rails have the similar way I have done here. So using this, we can achieve the you can say the DDD approach. Through DDD approach, you can segregate the code. Also, like whenever you have to design an API, whenever you have to design uh, some complex logic, we can start something from core itself. Like we can directly go to the core, and inside the core we can write the services like user service, the employee service, and we can design a domain model first. Like if some service comes, then we have to think about the what can be the possible domain models, and what can be the what are different types of services do we need. And based on that, later we can create an APIs, and accordingly we can serialize and send data to client. So this is all about hexagonal architecture. So basically, I name it as a CCD, the core connector delivery. Core is basically for business logic. Connector is basically for connecting database. If you see the connector logic over here, then you can able to see like I have basically write a logic to load database.yaml and inherit to the active record base. You can write if something S3 bucket comes, like you have to integrate the S3 bucket. That logic should come in a connector. You can create one folder over here inside the maybe the DB and the S3 over here, and you can write the logic like connecting here. So you can give a proper class like the S3 bucket, and you can utilize those functions, those classes in the service. So our service code become much more cleaner and readable. So this is all about the code walkthrough. Let me go back to, oops. So this is the aim of the hexagonal architecture is loosely couple the application components that can be easily connect to their software environment by means ports and adapter. Like there is a famous like design pattern ports and adapter. It is like that. And this is something what I have like in what I have discussed in the code walkthrough. This is something the domain is always on your first. The infrastructure, the repositories and application is evolve around it. Like whatever we need, like we just create and we just import those classes. Yeah, this is already I have discussed like the this I call the CCD, core connector delivery, which will makes code much more readable and maintainable. So yeah, so this is one more like diagrammatical representation, like how the code flows from user interface. It goes to the application layer, which is the service. From this service, it called the domain layer, where we have the user domain model, for example, the person domain model. And through that, it called the user repository, and user repository will return back the result to the security service, and security service will return back to the security API. So this is the flow of the layer architecture. So these are few references that I have used for this presentation. Also, like why we need DDD, then when to use DDD. So basically DDD and hexagonal architecture are intended to be for large scale applications. Like sometimes what happen, like if some changes we have to do and we have some nasty code, then it will become harder to debug or harder to do some changes. For me, like maintaining a good code is directly proportional to scaling your code, like scaling your business. So this is the way like you can define You can create repositories through Sinatra, and you can scale the application. And yeah, I think this is pretty much. And if you have any doubts, like or any question, like, over to, this is the QR code. You can connect me to this. And yeah, thank you.